Morning.
It's Baisakhi from DPS Damanjodi. I'm a student of Githar, SS Githar.
Mm-hmm. Nice.
So, my question to you is George Lemaitre, a well known Belgian cosmologist, proposed the Big Bang Theory. How far is it true? Can you believe it? Was this infinite universe expanded from that much small singularity? It's obviously a fascinating theory. So, what's your take on this?
Yeah, that's a good question. That's a really
Thank you.
good question. Most space scientists are trying to answer when we go to visit another planet, we take it or take an image of a star, or we try and understand what the chemistry is on Venus or anywhere else. We're trying to answer one of three questions. We're asking, where did we come from? Where are we going? And are we alone? Those are the three principal questions that space scientists are seeking to answer. Where did we come from? Where are we going? And are we alone? And so when Georges Lemaitre
Yes.
proposed his theory about a Big Bang that started from a singular supermassive seed and spread throughout the entire universe,
Entire universe.
that was revolutionary. That was in 1931, which is almost 100 years ago now, right? So over that period of time, scientists have debated the theory and refined it and taken measurements to help them better understand the universe and relate it to his original theory. And over time, there have been amendments to that. And the latest one that I'm aware of is not that it all started from a single place, but that the Big Bang actually started everywhere. So it wasn't that there was like one concentrated supermassive seed, but it was this emergence of matter. And to be honest, do I think that's the way it happened? I can say categorically that I do not know, and neither do the other scientists.
No one knows it, yeah.
Yeah, but it is a fascinating theory, and we're constantly asking ourselves, how far does the universe go? If I could go up right to the edge of the universe, what would be on the other side? These are just fundamental questions that are not only science, but they're also philosophy, and a little, you can throw a little religion in there as well. So perhaps because you've asked such an awesome question, and you were brave to go first, by the way, perhaps maybe you'll go to university someday and become a cosmologist and help refine Georges Lemaitre's theory.
Thank you, sir.
He's sending.
Well, there he is, I think.
Yes.
Oh.
Yugrala voice. Yes. Ask your question. Ask your
Yes, sir.
Yeah. Yes.
Sir.
Ask your question, please.
Sir, I have a question.
Please ask.
What is Artemis mission?
What is the Artemis mission? Yeah, that's a really great question. Are you finished or are you breaking up?
Yeah, no. Actually, that's the question.
That's a good question. So Artemis is a program that's made up of a series of missions, and that program is a coming together of space agencies and private industry from around the world to send human beings back to the moon. And when we went to the moon in 1969 and the early 70s, we did it just to prove that we could do it. And there was a great deal technology invented to be able to do that. But after we did it, we came home. And what we intend to do with Artemis is go and build a settlement first around the moon. We'll call that the gateway, and then on the surface of the moon. And that settlement would be permanently occupied by human beings from multiple nations, perhaps even India. And that will be the starting point of moving further out into space. So we have the International Space Station that's in low Earth orbit. Eventually we'll have the gateway, which is in orbit around the moon, and we'll have a settlement on the surface of the moon. Everybody doing their part to do the science and do the engineering, as well as to maybe even harvest some of the products that we find on the moon, and maybe even bring some of them back to the Earth. But certainly we're thinking that there might be water ice in some of the shadowed craters on the moon that we could then turn into rocket fuel. And so we could refuel rocket ships at the moon instead of having to bring them back down to Earth. So that's one of the purposes of the Artemis mission. The bigger purpose is to get humanity to come together and work peacefully on a grand project. And then from there, we'll go on to Mars.
Okay, thank you. So now we move on to the Dugirala MUO, sir. Sir, please respond.
Pardon me, I have a bit of a cold.
Yeah, no problem. By the way, Jim, actually,
Sir,
Jim, I am
good
trying
morning.
free Zoom version at this moment. So this free Zoom version can allow me for another 8 minutes from now. So once these 8 minutes are exhausted, I request you to reconnect. I request all the participants to reconnect so that we can extend this session. Okay. Yes, go ahead, sir.
Good morning, Jim sir. This is Srinivas Rao working as a monitoring officer in our state's education system. At first, thank you for your splendid presentation, sir. Today, I'm lucky enough to be a part in this session. Session really set off me on my new path of astronomy journey. This is a fascinating subject to me, sir. I hunger for deeper understanding and disseminate this subject with the motto of think beyond the earth. Thank you, sir, by spending your priceless time for us. My first question is, sir, is James Webb Space Telescope a successful mission or partially successful? We came to know it's one of the mirror was damaged with the impact of a small asteroid. Its functioning is 7% now.
Yeah, so it's a very good question. Lots of good questions today. So when an engineer in the space sciences designs something, it could be a telescope, could be a propulsion system, could be solar arrays, doesn't matter. We always try and determine what is the absolute necessary parameters. And in this particular case, the James Webb Space Telescope is designed to take certain kinds of images in the infrared with a certain accuracy and certain depth. And then what engineers do is they add margin on top of that. So the size of the mirror that you see on the James Webb Space Telescope is actually much bigger than what's needed in order for James Webb Space Telescope to accomplish its mission. And part of that reason that we made it so much bigger is because we knew that there was going to be micrometeoroid damage to the mirror over time. And so it came as no surprise to NASA that there was damage to the mirror, to one part of the mirror. but it was also not worrisome because we've got plenty of margin against the requirements for James Webb Space Telescope to meet its mission. And so the answer is yes, the James Webb Space Telescope remains 100% successful. The only surprise in all of this is that it got hit by that micrometeoroid so soon after it got deployed. But other than that, it's performing flawlessly, and people are just thrilled. So, and good luck with your new interest in astronomy. It's a fascinating subject.
Okay, thank you so much, sir. Yes. Okay. Okay, you can speak. Okay, you can ask.
Hello.
Yes.
Hello.
Hello. Good morning, sir.
Good morning.
I have a question for you, sir. This is Nagsai from 10th class ZPHS Kathmandu. Can I ask,
Oh, sure. Go right ahead.
why can space junk be dangerous for astronauts?
Why can space be dangerous for astronauts?
Space
Ah.
junk.
That-
Space junk.
Space is a dangerous place.
Space
It-
junk. Space junk. Space junk.
So, yeah, space is dangerous. We just talked about micrometeoroids. If you get hit by a micrometeoroid in space, it's going to puncture your spacecraft. I'm sorry. I think we need to close the mic until I'm done with this question.
Yeah, please.
Yeah. So if you get hit with a micrometeoroid in space, it's the end of the mission for you, in most cases, right? The other really dangerous part about space is space radiation. The Earth is uniquely situated. It's got this magnetic field that's constantly protecting us from the charged particles from the sun and galactic rays and that sort of thing, so that we don't experience as much radiation on the surface of the Earth as the astronauts do that travel out into space. And so one of the things we're looking for are ways to mitigate, that means to reduce the effects of radiation on astronauts as they travel even further away from the Earth out towards Mars, where they'll be totally exposed to space radiation. Another thing that happens to astronauts in space is if you're not using your muscles in gravity like we are right now, like I'm using my muscles to sit up straight, they begin to atrophy, which means they lose their strength. And that atrophy has to be taken care of, or when they come back to Earth, they won't be able to stand and their bones will get really brittle and that sort of thing. So there are health reasons that we have a lot of doctors that are watching astronauts and trying to figure out the best treatments for them as they spend longer and longer periods of time in space. That's a great question.
Okay, thank you.
Harry,
Yeah, thank
what's
you.
next?
Yes, I request all the participants to reconnect one more time, because we have 1 minute time is left in this particular free Zoom version. So I request all the participants to reconnect and click the same link so that we can continue the session. So I request Jim to join again once.
Okay.
Yes. So yes, please. And I request you one more time, please raise your hands so that I can recognize you and I can call you, please. Say good evening, sir.
Hi, sir. Good evening.
Good evening.
Good evening, sir.
Ask. Okay, just a minute. Okay, Jim, you can respond. Yes.
All right. Can you hear me now?
Yes. Ask.
I have a question, sir. Can I ask you?
Ask.
So please explain the interpreted in the Interstellar movie.
Ask it.
So can you repeat your question because I did not understand?
So please explain Tesseract interpreted in the
Oh,
Interstellar movie.
so the tesseracts, is that right? So if I've understood the question correctly, a tesseract in mathematics is a way of representing a cube in 4 dimensions or 5 dimensions, I think, in 5 dimensions. And it's a way of trying to visualize the way things might look in dimensions, dimensional space that we don't have right now. So that's what it is in mathematics. In science fiction, in the movie Interstellar and in some other movies, they use the idea of a tesseract to imply that there are special ways that people in other dimensions or life forms in other dimensions can communicate with human beings. I have to say that right now, that is science fiction. But that doesn't mean that it isn't possible someday to communicate across dimensions. It's just that we don't have the physics yet today to be able to do it in real life. It's fun though to think about when they work that sort of thing into movies. So that's a really good question too. I hope you like science fiction. I sure do. And if you look at some of the technology we have today was actually predicted first by science fiction. So
I have a question, can I, sir? For
I can.
interplanetary travel or interstellar distance is the main barrier. Is it possible to conquer humongous hurdle to mankind? Is drive technology possible, sir?
Yeah, it's an interesting question as well. So many really good questions today, Harry. I'm telling you, these students are thinkers. And if you remember the last slide or one of the last slides I showed you in my PowerPoint presentation, I said it would take 500,000 years for us to get to the exoplanet that we were talking about. If we traveled as fast as we possibly could, as we know how today. And you're exactly right that it is the extreme distance that limits us from being able to go to these places that we can see with telescopes, which is, just as an aside, it's amazing that we can see those things. And if you think about what happens is there's a planet 42 light years away. The star it's orbiting shines on that planet, and the planet reflects light that then travels for millions of years to end up in a telescope that enables you to be able to see it. And in that way, it's a little bit of like a time machine, isn't it? So actually 42 light years, it's only the light that you're seeing is only 40 years old, but you're seeing that planet as if it was 40 years ago. And so what would be interesting is if you could travel all the way up to the speed of light, it would still take you 42 years to get to that exoplanet that we talked about today. So in Star Trek, which is again science fiction, they talk about warp speed. And if they say warp 1, what they mean is you're traveling at one time, you're traveling at the same speed as light. If they say warp 2, then they mean 100 or 10 times the speed of light, and warp 3 is 100 times. And it just keeps on going by factors of 10 that way. Is that possible? Not today, it's not. Not until we come up with some new sort of physics. there are scientists that are testing some theories that would enable us to move particles, very, very small things, up close to the speed of light that would cut the time it takes to get to places like Jupiter and Pluto down to months instead of years. But that still would not conquer the distance even just between us and our closest star. So it's a thing where we are going to have to continue to invent technology that would help us go faster and faster. One of the important things to remember is if you can get up to speed and go really, really fast, you can cover that distance in a shorter amount of time. But you got to remember, you have to slow down when you get there. And so that becomes just as big a problem as getting up to speed. So great question.
Okay, thank you.
Harry,
Yeah,
what do we got
thank you.
next? Here too.
Sir, can I ask you a question? Is time travel possible?
Oh, you know, um, until we break the barrier that we seem to have with the speed of light, then I would say no, time travel is not possible. Again, there are scientists that are working on trying to travel faster than the speed of light. And when you do that, then classical physics says that you will be breaking the time barrier. But all of these things are fascinating because they are things that were conceived in the imagination of man. And so we have human beings that have an imagination about maybe being able to travel faster than the speed of light. Well, just because I say today it's not possible doesn't mean that in some time in the future that we won't be able to. And I think that what we all need to be doing is raising generation upon generation of physicists and space scientists that will be looking at whether or not we can break those barriers that keep us basically tied to this solar system right now. But it would be cool if we went from the International Space Station to the moon, then to Mars, and then to another star. And hopefully we'll be able to
Thank
figure
you.
that out.
Thank you.
Thank you. Thank you, sir.
Dugirala girls. So raise your hand. Yes. Yes, you can. You can ask your question.
Good morning, sir.
Good morning.
I have a question, sir.
Go ahead.
How could solar Parker probe withstood against the enormous temperature of corona?
Yeah. You know, I actually worked on Solar Parker probe for a little while. And the probe has a really unique covering, like a shield in front of it, that enables it to withstand that heat. But you know, withstanding heat is a combination of not only insulating from that heat, but also reducing the amount of time that it's exposed to the heat. So what the Solar Parker probe does, which for the others that don't know, it dips down and goes into the sun's corona. And so it's actually touching the sun. It's moving so very fast. So we make it go really fast when it does that. So it goes down and in and out. And so then once it comes back out, the surface starts to cool off again, and they get it ready to go down and dip again. So that's how the Solar Parker probe, it's a combination of the materials and the time of the exposure to the heat.
Thank you. Prakash Rao.
There we go.
Harikrishan, we are ready to ask the question.
Yeah, please ask.
Good evening, sir.
Good evening.
I have to ask you a question.
Yeah, please go
I
ahead.
have to ask you a question.
Yeah, go ahead, ask me.
Go right ahead.
What is the result of Large Hadron Collider experiment?
Ah, I saw that question in advance. As somebody who's well informed, I have to tell you, I don't know. The Large Hadron Collider is a project of the CERN in Switzerland, and it's fundamental physics investigations, and really less to do with space and more to do with trying to understand the makeup of atoms and subatomic particles. But I will tell you that I have a friend that works on the Large Hadron Collider in CERN, and perhaps if Hari's interested, we could have her come and talk to you about the LHC someday. So
It's our pleasure. It's
Yeah.
our pleasure. Yeah.
So thank you very much, sir.
Sir, I think Voyagers, both Voyagers and Pillars of Creation, Eagle Nebula, are having a sentimental attachment to astrolabers.
So-
Where is Voyager now? How far it is traveled? Is it still in active mode? And another one is Eagle Nebula still there in the universe?
Okay, so you're breaking up, and I'm not exactly sure what the question was that you're asking.
Srinivasara garu, could you please ask one more time?
Yeah. One more time.
Okay, one more time.
Sir, Voyager spacecrafts are the sentimental, we have sentimental attachment to astrolabers. In fact, is it still in active mode? Is it sending pictures or any data to NASA?
Oh, are you talking about WISE? The WISE
Voyager,
spacecraft?
Voyager. Yeah.
Yeah. Let's see. The WISE spacecraft was originally an infrared telescope that we kept it cool by having a block of solid hydrogen that kept the detector cool. Eventually, that warmed up and the hydrogen bled off, and we repurposed the WISE telescope to look for asteroids. And the end of that mission has come now, and the WISE telescope is not operating any longer, to my knowledge. All of these things that we design, they have prescribed lifetimes, and the WISE outperformed its lifetime and did really well and contributed a great deal to our understanding of asteroids and infrared astronomy.
Okay, thank you. So, Peddavaram.
Good evening, sir.
Good evening.
I would ask you a question, sir.
Go right ahead.
Sir, what is going on in ISS and what is the lifetime of ISS?
Oh, yeah. Also another good question. You know, when I got out of college, I worked for a company called General Electric, and GE was building spacecraft. And one of my very first jobs was to help design the International Space Station. That was back in 1979, right? Well, we first started assembling the International Space Station in 1998. So it took from 1979 to 1998. What is that? 19 years before we actually started building it. And the first mission went up to start building the ISS in 1998. And if you look at when the International Space Station partners have agreed that the end of the ISS should come, they've said that should be 2031, right? So you do the math, and that comes out to about 33 years is the lifetime of the International Space Station. Along the way, there are things that we have to repair. Solar arrays don't work. reaction wheels, these big things that keep the station stabilized. They have to be replaced. Electronics wear out, those sorts of things. So we have a program to do the maintenance necessary to extend the lifetime of the ISS. And it's very probable, if you ask me, that we'll get really close. We'll get really close to 2031, and the partners will again agree to extend its lifetime out beyond 2031. Because fundamentally, as long as you do the maintenance, there's no reason it couldn't continue to operate, except that the countries might want to go do other things by then, hopefully around the moon. Yeah.
Thank you. Jet pages.
I want to ask a question.
Please go ahead.
Recently, NASA informs DAFT mission impact changed in a asteroid motion in a space. Can we use this technology to avoid future impacts, particularly during Apophis? Asteroids fly by in April 13, 2029?
Yeah. So first thing I'm going to say is that the more we observe Apophis, the more we are confident it's not going to hit the Earth. It's going to come very, very close, but it's not going to hit the Earth. So I don't think you need to lose any sleep over that. It's don't worry, we're safe from Apophis. But it is very important that we understand the physics of asteroids so that if we ever find one that's coming inbound towards the Earth, that we have a way of redirecting it. And one of the things is, if you find it early enough, you just have to give it a little bit of a nudge, because that nudge over time gets multiplied to bigger and bigger separation angles. And you just give something a little nudge, and eventually it'll just move out of the way of the Earth, and they won't collide. And that's what the DART mission was intended to prove that we could do. But we did it on the moon of an asteroid that we knew was not going to hit the Earth, so that we were safe. Just in case something went wrong, we wanted to make sure that that if we hit it, it wasn't going to come back in and enter into the Earth's atmosphere. So the DART mission was very successful, and that's exactly why we did the mission, was to prove that we could do it if ever we needed to, if we found an asteroid that was inbound that might harm human populations.
Thank you. Donna.
Hello, sir. Hello, sir. I am Lohita Girija. I am a 9th grader. Could you allow me to ask a question? Sir, please explain black holes, quasars, and blazars. Please explain black holes, quasars, and blazars.
Please explain.
Black holes, quasars.
Oh, black holes.
And blazars.
Yeah. Right. So, so black holes are thought to be the formation of a dying star, where it collapses in upon itself, and the more it gets closer and closer together, the more gravity it attracts, the more things it attracts, the more falls in, the bigger it gets, and it continues to compress itself, and it becomes so massive that it affects space, and some think even time, in the vicinity of the black hole. In fact, part of the reason that you see our galaxy has a spin to it, if you look at pictures of our galaxy, it has these spiral arms. Part of the reason for that is that there is a supermassive black hole at the center of our galaxy that keeps everything in our galaxy kind of like in order. And so, we couldn't exist in the Milky Way the way we do if it weren't for black holes. And there was something else that you wanted me to talk about. Oh, quasars and blazars. I have to tell you, I'm not a radio scientist, so I really don't know that much about quasars, other than I know that they're um, regular radio emissions from possibly black holes deep into space. And as they spin, this radio emission comes and goes, and it's you can actually time them so you have an idea of when they're going to come back, simply because they're so repeatable. Yeah,
Thank you,
it's a
sir.
good question. Yeah. It's been a pleasure talking with you all. I see somebody's made up a sign with my name on it.
Yes,
Thank you.
it's my students. In fact, they made it with the colorful papers.
Thank you very much. So, so here's my question to you all. Raise your hand if you're going to study science, math, engineering, and technology at university. Raise your hand. I want to see
Right,
future
Stanley.
scientists coming from India. So, yeah, I see several. All right. I think that's an important career path, and it's not just good for you, but it's good for humanity. So in my book, if somebody came to me and said, "What should I study?" I would say physics or chemistry or mechanical engineering or anything that will ultimately help us understand space and our place in the universe. And I hope that someday that will be you. So everybody have a wonderful day. Hari, thank you for
Thank you.
going to the trouble of setting this
Thank you
all up.
so much. Thank you so much for your time. And before we end this session, may I do one thing, that is singing our national anthem.
Oh, sure.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जाहे तव शुभाशिष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत